Okay, the last thing that needs to be discussed about potential energy diagrams is that how they represent the effect of the catalyst on the potential energy of the reaction, the change in the potential energy of the chemical process. So here is the potential energy of the exothermic reaction, at least the forward reaction is exothermic. And right here, there is a bump of the activated complex. So for these reactants to proceed and complete rearing themselves into products, they need to achieve this heightened energy state of activated complex. Okay, what catalyst does through the providing the alternative route for the chemical reaction, they decrease the amount of energy that is needed. They decrease the amount of potential energy of the activated complex, and as a result, this entire bump decreases in height. We have to spend less energy to initiate the reaction in the presence of catalyst. So my initial activation energy was that high, and my activation energy when catalyst is present is significantly lower for the forward reaction. But the same can be true about the reverse reaction. If we look into this endothermic reaction, yes, we know that the activation energy for the reverse reaction is going to be pretty high, but the catalyst, the presence of the catalyst decreases that activation energy into this one. These green arrows represents the activation energy of the reverse reaction. This one over here, this is the amount of activation energy of the reverse reaction without the catalyst, but with the catalyst, the activation energy became smaller, and as a result, the reverse reaction will be happening a little bit faster as well. But still, nature will favor the exothermic reaction of traveling of the forward reaction over here. The same applies to the potential energy diagram of endothermic reaction. Here, the forward reaction is endothermic, reverse reaction is exothermic, and if we apply catalyst, then for both forward and reverse reaction, the activation energy will decrease. So for our forward endothermic reaction, the activation energy used to be that high, now it is smaller. And for our reverse reaction right here, the activation energy used to be that high, now it is smaller. So application of catalyst will speed up both the reverse and forward reactions in equal measure. But please notice and pay attention to the fact that application of catalyst does not affect potential energy of reactants or products. Nothing really changed over here. It is still the same level of potential energy of reactants and products, and application of catalyst does nothing to the heat of the reaction. It used to be 53 kilojoules, it's still 53 kilojoules.